Hi. In the speech field, all of us like to design some classifiers and vary their parameters to find out what happens to the performance on a given task and a dataset. As long as we are in full control of the experiment, we can learn how these parameters are impacting performance. There are, however, situations when we may not know all the details or be able to control the classifiers. This would be typically the case in benchmarkings or challenges where we may have access only to the detection scores, but not necessarily all the details of the classifiers. In this work, we would like to see what else can we say beyond the error rates and DET profiles in this kind of setup. In particular, we propose to visualize classifiers in a two-dimensional space so that each of these classifiers becomes one data point. And by producing this kind of presentation, we can visually compare similarities and differences of the classifiers. You will find the details in the paper, but this is simply done by computing the distance between each classifier pair using rank correlation statistics and visualizing the distance matrix with the classical multidimensional scaling. By doing so, the hope is that those classifiers that are more similar on their design parameters would be also then nearby located in this space. And those that are more dissimilar will be further apart. So let's look at some actual data. This is speaker recognition experiment on a VoxCeleb corpus with a GMM-UBM system. The numbers indicated are cost of log likelihood ratios, and the 4 shapes that you see here correspond to a different number of male filters in our MFCC frontend, whereas within each of them, what we vary is the number of Gaussians. So in this case, we can see clearly what is the impact of these two parameters on these similarities of the classifiers. So let's look at another data. This is voice anti-spoofing task on the ASVspoof 2019 logical access dataset. What we do here is we show the different feature front ends as reported by the challenge participants. In this case, we don't see as clear trends or tendencies as in the earlier controlled experiment, simply because we don't have all the information or the exact metadata available of these systems. However, we can still see that systems with similar front end can be located near to each other in this space. And in general, this kind of visualization tool can be used for breaking down any classifier system scores. So if you got interested, you can find the pointer to the code here. Thank you very much.